Hi everyone, and thank you for inviting me here to St. Petersburg. It's actually my first time in Russia, so very nice to meet you all. Speaking of that, have I met anyone else in here before? And speakers don't count? No hackathons, conferences, no? Okay, I kind of thought so. So let me tell you a little bit about myself first. So I'm from Sweden, where winter's always coming, just like Russia. So it's almost like home. And I worked with JavaScript for a long time, and I especially did it from my sofa as an entrepreneur in good company. And the first thing I did was working on JavaScript ad tracking in the browser. You know, not the kind of thing you would see because you all use ad blockers anyway. And then I started a company working on customer feedback, where we did everything in JavaScript. So we had a Node backend, JavaScript apps, web apps, and so on. And then for a while, I did consulting in JavaScript as well. And we did lean consulting, so lean that we skipped Office and just focused on coding. And then I worked on an app called Fishbrain, which is an app for sports fishing, where we also used JavaScript for the backend. And it's used today by millions of anglers all over the world. And then today, I moved on to working for a hedge fund in London, and that's about as much as I can say about that. So, I mean, luckily, I'm not here to talk about any secrets or my own entrepreneurial projects, and that's not why you guys are here either. I'm here to talk about my own love and passion for JavaScript. And the purpose of this talk is to talk about a couple of things you might have forgotten. Things that you maybe never knew, or maybe didn't think about that you knew. So that's why the title of this talk is The Forgotten Funky Functions. And we will talk about the true powerful building blocks of JavaScript. We'll talk about why the old JavaScript was powerful, and we'll talk about how the new JavaScript is adding to this. And along the way, we'll try to do some dark magic with everything. So the plan looks a bit like this. We'll start with an example to dive straight in, give you an idea of what I want to talk about. And then we'll discuss a little bit why JavaScript is different from other languages and what I think real power in a language is. And like I said, we'll also look at how ES6 is increasing this power. And all the way, we'll do some examples and fun stuff. So code mixed with some philosophy. But let's dive into it. So if you have a function in JavaScript, and you want to get argument names for that function, how would you do it? I mean, to be concrete, we might have something that looks like this. We have a function that takes a first name and a last name and produces a first person's full name by just concatenating the two. And we want this argnames function implemented. We want to pass in the full name function. We want it to return an array of the strings that it takes as arguments. This is not hard, but it's not obvious because JavaScript doesn't have an API that does this. It doesn't have meta programming in the same sense as many other languages. But we can do it quite easily by just toStringing the function and then getting the entire definition of the function available, parsing it, picking out the argument names, and returning them. So we really, really can do things like this in JavaScript. How many have done this, or something like this? Yeah, there's a few hands. Good to know that I'm not alone, but also good to see that everyone's not quite as crazy. And I think this creates a divide, because some people say that this is ridiculous, this is stupid. And some people say this is freaking awesome. And I mean, we can very easily access all of this information in our functions. We can know exactly how they're implemented and how they're going to work by inspecting them. If we just parse the JavaScript, we can do anything with it that any other language that actually has those things built in could do as well. But in JavaScript, it's so simple. We don't need an API, we don't need tools to do this. We just have this primitive of turning it into a string and doing whatever we want. And I think this is a good example of this divide in JavaScript, where some people think that that's crazy, that's stupid, and some think it's amazing. And you know all about the jokes about how, like, yeah, this is JavaScript, and that's the good part, and there are tons of blog posts on what we hate, and the stupid comparisons, and the types, and everything about JavaScript. But still, JavaScript is the most popular language by far if we look on GitHub. And you know, GitHub is the place where no corporation or boss forces you to use a particular language, but you get to choose. You put up your own project. And obviously, people are using JavaScript the most. Even though Swift and TypeScript are growing the most, JavaScript is still growing as number 3. And Swift and TypeScript are very new and small, so it's easy for them to grow quickly. And also, TypeScript is really JavaScript, right? So it's definitely about JavaScript. So the reason I think there's this conflict and that people love it and hate it at the same time is that we're asking ourselves 2 different questions when it comes to the language and the development of the language. And the first one is, which language should we be using in the browser? How should that language work? So when we think about the browser, everyone just wants all of their own favorite features from their own favorite language into the browser. I think the majority of people who has experience coding something else and then got into web development have been cursing and saying, why have we not got this feature and that feature? Why do we not have classes? Why do we not have modules? Why do we not have lazy evaluation or all the other things you have in the language you're used to? And you kind of have to relearn everything, and you get mad and just want your stuff in there. And I think that's a legitimate complaint. Of course, there are different languages, you like some, you dislike some. Of course, you can have that opinion. But if we take that opinion and just listen to everyone and start putting all of those things into JavaScript, it becomes like that old joke about C++, where Bjarne just took C, and then he thought, what are all the things I have ever heard about, and just put them into the language, kind of like making an octopus by nailing legs onto a dog. And it's still a dog, but with lots of new features. And this is not how you want to do it. This is what happens when everyone wants to put their own language into the browser. So, what's the other question? The question we should really be asking ourselves. It's, what do we actually want from this JavaScript language if we look at it as just another language, not a tool of the browser in particular? So JavaScript is not just for the browser anymore. It hasn't been for a while. We've had Node.js for long. We have embedded environments. We have databases where you use JavaScript as a query language and so on. And then you might ask, why do we need this JavaScript? Why is that still in there? Why is everyone using this thing? Why not just use another language? Why is this so popular? Well, I think diversity is good. I think being different is good. So we have JavaScript because it's different, not because it's the same as all the other things and because we bolted everything onto it. And all of them have different strengths, right? It's okay to be weak in some areas if you're strong in the others. And I think a lot of people who come to JavaScript get this wrong. So to me, it's something like this. Depending on how you enter JavaScript, you have a different satisfaction curve using it. So the red one are obviously all of those people who are used to another language. They come in, it looks very familiar. This is like C syntax, there's semicolons, I'm going to be happy using this. And then it plummets because nothing works the way they expect. And then after a while, they learn the quirks and kind of get back into it. And then there's the blue line, all the new developers who who don't know any other language to begin with, and they just learn. It's just they're adapting to this thing. This is normal. This is coding. But then there's the people who come to JavaScript by choice, who think that there's actually some merit to this. There's something interesting about this language. And those discover those things and see that, wow, this is kind of cool. And then you discover the bad parts and take a dip, but then you realize how to work around them, how to not have to deal with that, and you get quite happy. And what is this reason then? What's the difference in JavaScript? How can we be happy using this language? Well, an obvious difference compared to many other languages is that it's dynamically typed, of course, but other languages are too. It's not like being dynamically typed is what makes a language good or bad, it's just different. I mean, we have R, PHP, Ruby, PowerShell, if anyone uses that, Clojure, Dart, Perl, Smalltalk, Scheme, tons. So that's not the differentiating factor. But there's the script part in JavaScript. JavaScript was made to be simple. It's made to be a lightweight tool. And maybe you know the story already. Everyone's heard how Brendan Eich created it back in '95 in just 10 days because he really had to rush something out from Mozilla. And he called it Mocha originally. And then a couple of months later, when it made its way into the browser, they called it LiveScript. And then because of marketing, they changed it to JavaScript because Java is popular and it kind of looks a little bit like Java. And yeah, then it went on to be something that all browsers could implement by going to ECMA, standardizing it, and eventually having something that you could conform to. So it's really, really created to be simple. It's for scripting, it's for doing things in a lightweight way. And I think there's 4 things in JavaScript that makes it good for scripting, good for these simple tasks. And first off, we have the thing discovered by Douglas Crockford, which is the beautiful inline data, JSON. I absolutely don't see how anyone could not love this, because all other languages are emulating this now. They're all implementing JSON parsers. They're all passing JSON back and forth. No one likes XML anymore. It's about JSON. And JavaScript has this natively in the language. It feels like writing the data when you code. And secondly, we obviously have the first-class functions and their closures, which is what brings the real power in writing logic in the language. And I find this funny because for the longest time, the mainstream languages like Java, C#, C++, PHP, they didn't have this. And it reminds me about a joke from one of the best blog posts I've ever read called A Brief, Incomplete, and Mostly Wrong History About Programming Languages, where they say that in 1970, Guy Steele and Gerald Sussman created Scheme. And that work led to a series of Lambda papers, but still Lambdas were relegated to obscurity until Java made them popular by not having them. So this actually became really popular because everyone missed it. And like Crockford says, if you have a problem, you just need another function. So you should all know this, but I feel like a lot of people don't. So let's take a quick example here. Let's look at the once function from Lodash and underscore, which is, if you don't know what it does, it looks like this. It gets past a function, I've just called it init here, and then it returns you a new function, which will call the first function, but just once. So even if you invoke this multiple times, it will just call the original function one time. Very simple, very obvious. In JavaScript, you would implement it by creating a closure, keeping track of if your function has been called, what the return value was, and then pass back this new function that just takes whatever argument, we don't care, We check, has this function been called before? If not, call it, save the result, set the flag, and then return the result. And the next time we can just return the result immediately. This is the bread and butter of JavaScript, obviously. If this is not 100% familiar to you, then familiarize yourself. And you can obviously do this on more complicated examples where you have multiple functions and do something more advanced. Like this little example, I always used to write when I did Node before promises and before there were ways to really deal with the async flow in a nice way. Or when just writing something very simple where I don't want to pull in a couple of libraries. So let's say you have a little example like this where we want to get the first name of a user given some API. And we pass in the ID of this user and we just call get for the user with that ID. We then get an error or a response, and if we have an error, we pass that back to the callback, and if we don't have an error, we pass the first name back, right? Super simple. But we don't want to do that error handling multiple times in our code. It looks horrible, and it's just not convenient. So what I did, and I'm not saying you should do this instead of promises, this is just a little example to show how you could simplify this in a short, simple script. It was to do something like this, where we create this function called propagate, which takes the callback and then just handles the success case. So there's no error here. We never deal with the error. We just wrap our callback in propagate and then give this success case. And that's it. We don't have to see the error handling. It's going to be passed up the callback chain anyway. And once again, super simple to implement, right? We pass in two functions. We pass in something to handle the errors. We pass in something to handle the success cases. And we return a new function, which gets the error and all the rest of the arguments, whatever they might be. We check, do we have an error? If we do, call the error handler with the error. And if we don't have an error, call the success handler with the success results. Really, really simple, but it's capturing that logic that you don't want to repeat, and it's doing it by working on two functions and returning yet a third function. And like I said, I don't want you to go home and use this function like this, because we have better tools now. But you can use this principle in everything you do to make things easier. So don't let this be magic. This has to be understood. This is what JavaScript does, and does really well. Many other languages can do this as well now. Many of the mainstream languages have support for lambdas and closures, but it comes more natural in JavaScript than in most of those, I'd say. And since we don't have typing, we can really do anything with it that we want without being constrained by the type system. And if you want to read some more things about this kind of power features of languages, there's a blog post that I'd really recommend by Paul Graham, which is called Beating the Averages. It's on paulgraham.com/avg.html, or just Google Beating the Averages. So that was the first-class functions. Then we have the async nature of JavaScript, which is not really a strength, but it's a differentiating factor. It's something that makes JavaScript different from most of the other scripting languages out there. A reason to use or to not use JavaScript, depending on your use case. So it's like this because JavaScript started out async. It was supposed to be used in the browser, on the user interface thread, where nothing could block. You can't sleep, you can't wait. So all our functions that would do things that takes time, like timeout or the XHR for requests and so on, they all had to be async. They all had to take callbacks to deal with their results. And obviously that was very easy because you could pass around functions like you can in JavaScript. So there's there was a lot of problems with this. There are still a lot of problems. We're still dealing with kind of taking care of that, figuring out how to work with this in an easy way. But it's one of those things that makes JavaScript different and makes it powerful if you need to do things in an async way, because the language is built around it. And then the fourth point. So now we get on to some of the juicy stuff where we get to do crazy, crazy things. And it's the fact that JavaScript doesn't have proper meta-programming, but it still allows you to do all those things that a language that has spent a lot of time building a powerful API around meta-programming allows you to do. You can still do the same things in JavaScript. And like we saw before, it's centered around being able to run toString on a function and also evaluating any string as if it were code. And now some people are sitting in their seats and like, oh my God. But this is not something you should do every day, but it's one of those power usages. So let's take an example again. Let's say we have a function, the same function as before, that just takes a first name and a last name and produces your full name. And for some reason, we want to be able to call this function with an object argument instead of positional arguments. So I want to say that my first name is this, my last name is this, named, and pass that in. And I still want it to work. How would I implement this args as object function that transformed the first function to the second one? And this is adding on that I've actually done things like this, because when you have an API or you have something you want to call via rests or so, you usually want to pass things as arguments as opposed to by position. And maybe you have functions already that are based on positions, and you don't have to refactor that. You could use this function to just make them callable by name instead. And this is simple, but it's not usual, right? So you'd implement it something like this. You just take the original function and you get the argument names from it using the function we saw before. So we now know what the names are called, or what the arguments are called. And then we pass back a new function. And this function just expects one argument, the one containing all of the actual arguments. And then we use the lists of names that we retrieved and go over them in order and retrieve the corresponding property of the arguments object. And suddenly we will have a list of all those things in that order as you expected your argument names. And then we just call the original function with that. A little crazy, right? But it works absolutely fine. What if we are a little bit crazier yet? Let's say, for some arcane reason, I don't know why, but let's say you want to rename these arguments before you expose it on an API. You want it to be snake-cased instead of camel-cased, because that's what your other language wants it to be, or whatever. So we have the full name function, and then we want to call rename args on this function and say, these are the new names I want my function to call the arguments. And then once again, we do convert it to a function that takes an object, and now we call that with snake-cased arguments. How would you implement this? Any ideas? So we have to go nuts and use eval. It's simple. You can read it yourself. We basically just create a new function, join in the argument names that we want, and wrap that around the original function. Which means that if anyone looks at this function when it's been returned, it's going to look like the arguments it expects are snake-cased now. It doesn't make a difference for the program, because we're just passing the arguments through. We don't use the names. But we can do this so someone reading your things expects something different. So eval can do truly magical things that we can't really do otherwise. And if we take another example of that, We can do capability testing of the environment we're in to see what does it support and how does things work. So for example, we could check, do we have support for arrow functions in this JavaScript we're currently running? And obviously we implement this function without using the arrow notation, so a regular function. And then we try to eval a simple expression using arrow notation. And if that throws an exception, then we don't support it. And if it doesn't, then we do have support for it. And obviously you could use this to do some selective loading of source code or some other funny thing depending on if you support this or not. But it's yet another one of those things you can't know for sure unless you use something like eval. That's a little mind-blowing, right? So we're always taught that eval is super evil and you should never use it. And that's because people used it all the time in the beginning because they didn't understand JavaScript. But eval is there for a reason, and there are use cases where it's powerful and where we can use it. We just have to do it responsibly. And it's very, very, very rarely the right answer, but sometimes it is. So I have a challenge for all of you. I want you to either tell me an eval story. When was one time you actually used it to do something that was awesome? Maybe not necessary, but it was awesome. Or come up with something. Now if you're bored today, you have nothing to do, the breaks are too long between the talks, come up with something crazy you can do with it that would be hard to do otherwise, and tell me. And I might use it in the next version of this talk. So, recapping the 4 cases for, well, JavaScripting here. We have the beautiful inline data, more convenient than most other languages. We have the first-class functions with the closures, which bring us the actual computational power that JavaScript has. So we can write almost anything just using functions. We have the async nature of JavaScript, which, like it or don't like it, just like the other things, if that's what you need, JavaScript might be the right answer. And fourth, we do have metaprogramming using eval and toString to do introspection and executing code at will. And this is all the original JavaScript. All of these were in there as part of the 10-day products Brendan Eich created. These are the things that made that awesome, and it's still awesome 20 years later, or 22 years later. But then we're back to that kind of scenario where we're now starting to bolt on a lot of legs to this dog. People are not happy with this. They want more, right? Which is why we're talking about the new versions of JavaScript. A lot is changing, a lot is improving. And in order to reason about this properly, what's good, what's bad, let's talk about power. Let's talk about what power in a language really is. So if we revisit the once function and think about what's going on here, it's doing something that a lot of other languages can't do. And that's the fact that called and result, the 2 variables there, they're truly private. Truly, truly private. Many languages allow you to inspect the code while it's running, to find values that are private, for example in Java or C#, by doing metaprogramming. You can access the private stuff. Nothing's really private. And then there are the other languages like C and so on that are low level, where you can always access this stuff by doing pointer arithmetic or basically hacking the language. But in JavaScript, you can't do this. These are private, for real. The function can access them, but it can't pass them over to anyone else. No one can read the values of these variables. And this is not due to some advanced feature of JavaScript. This is a design decision that this is how it should work, how closures make it work. And it's a bit like that old the omnipotence paradox, where you ask, is God all powerful? Because can he create a stone so heavy that he can't lift it? If yes, then he's not all powerful because he can't lift the stone. And if no, that means he can't create that stone. So you can't be all powerful. It's impossible for a programming language to do everything. You have to choose. Should I be able to lift the stone, or should I prevent myself from being able to lift the stone? And it's a bit like Lego. Because to me, power is about having really powerful building blocks that can do a lot of things, and you can use your imagination and turn it into anything. And that's how Lego started. And then Lego went the same way as JavaScript is, because suddenly we have all of these very peculiar, specific pieces that when you buy some Lego now, there are pieces in there that you can't really use for anything else, and they're just there to make you be able to build an X-wing or whatever. And it's losing that kind of imagination. Oh, I bought this thing, now I have to build an X-wing, okay. So that's the way I feel about ECMAScript 6, largely. That the important thing about developing the language is not about adding these very specific pieces that can do a very specific task, but we have to make the core more powerful. If we wanted to extend that list I had of those 4 things that make JavaScript different, what would the 5th be? What would the 6th be? It wouldn't be syntactic sugar. It wouldn't be about, oh, now we have classes. Oh, wow, amazing. Now we have built-in promises. Promises is a library thing. It's fine, we don't need it built in. It's not even about the arrow function syntax, which, I mean, it's super nice, but it's not changing how the language works. It's just changing how you're writing it. And I mean, be honest, everyone's transpiling JavaScript these days. Either you're doing CoffeeScript, or you're doing TypeScript, or you're using the latest ECMAScript version, which is not supported in your browser, so you have to port it back to regular JavaScript. So it doesn't really matter if the language itself contains syntactic sugar like that, because we're just going to transpile anyway. No, the important stuff is to make the language itself more powerful. And to me, there's one thing in the new JavaScript that makes it more powerful in this regard. And that's obviously the proxies. And the proxies are something I feel it's not just catching up with other languages in that sense, it's surpassing a lot of them, because it's giving us a capability we didn't have before. Now we can change the language to work in the way we want it to work in our particular application. So if there's anyone who hasn't seen or used proxies, it's very simple. It's just a type of object that takes 2 things when you create it. It takes a target object, which is any other object, and it takes a set of handler methods, which will intercept the normal behavior that JavaScript has. So in this case, we pass in an empty object. We set a handler for get, which is invoked every time we read a property of the object. And before returning it, we multiply it by 2. So even though we set x in this object to 5, whenever we access it, it's going to read out as 10. And that's obviously completely useless in this case, but you can do some amazing things with this and change how the language works. Yeah, pointed that out already. So the handlers touch all of the basic functionality of JavaScript, like how we define, delete, and interact with properties, how we interact with the prototypes, which basically control the behavior of our objects, how we find the properties of our object, how we extend it, and even for the last 2, how we deal with functions. What happens when we call a function, what happens when we construct an object from a function as a constructor. We can change all of these things And we can do things that are completely nuts, or things that are useful. So just a couple of things I like that are very simple, good examples is, for example, allowing arrays to have negative indexes, like this. So we have 3 values in our array, and we want to be able to ask for the last one by just saying -1. And that's something several other scripting languages, they do have this already, and JavaScript kind of has it with slice, but the syntax is not as nice. So if we really want it to work like this, we want to change the language to accept this, then we can. And we can do it for all arrays in the entire system without touching any of them, by just doing some magic, like this. So if we start from the bottom here, we start by getting the prototype of the array prototype, which is usually object, or the object prototype, unless anyone has been fiddling with it. And then we create a new proxy object from this prototype, with the handler we'll look at in a second. And then we change the prototype of array to be this proxy object, which basically means that whenever you use an array and you do something that's not already supported by the array, it will reach this handler. And what does handler do? Well, we intercept get. If anyone's trying to access a property, we check, is this thing a number? If not, then we just return undefined, because since we're doing it in the prototype chain, we will already have found the valid properties if there were some. This will just have been accessed if the property was not there. And if it's a number, a negative number even, then we just add that to the length of the array to move backwards in the array. And voila, we have negative indexes. Another thing I've missed since the beginning in JavaScript, since the first day I used it, is something similar to Ruby's no method, where you have some way of catching when you're accessing something that doesn't exist. So let's say we do something like this. We want to create an object that's strict in the sense that you should not be able to call something on it that doesn't exist, or you should not be able to add new properties by mistake because you spelled them wrong. So here I just have some name and a method, and I'm allowed to change the name, I'm allowed to call the method, but if I mistype it, if I write name instead of name, then this should be an error. You should not be able to access this. And if I write foo the wrong way, I should not be able to call it. And to be honest, quite often this is what we want, right? We don't need to modify the objects in new ways or call things that are not there. We don't want the subtlety of things failing because they come back as undefined all the time. Sometimes we do, but not always. Not most of the time, I'd argue. And once again, this is very easy to do with proxies. So that strict object function could be implemented like this. We could say that take the original object, make it the target of a new proxy, and override how we get and set properties. And in the implementation of both of those, just check, do we have this property? If yes, use the default behavior, which you can do with this reflect object. It has all of the primitive functions there. And if we don't have it, throw an exception. So suddenly, we're going to catch every time we're writing something wrong up front immediately, instead of discover it further down when our undefined has ruined a computation or something like that. Another way that's maybe a little bit more elegant than implementing it like this is to use the prototypes again. And not all the object prototypes, because we don't want all objects to behave like this. But we can do it in this way, where we create a proxy that's always throwing. There's no logic in the get and set. They just, if you come here, if you ask for anything, throw. And then we just make this the prototype of the original object. which is another way of saying, whenever we don't have something we're looking for in our object, go up the prototype chain, it tries to get something, and it throws. And if we were really, really crazy, we could obviously do the same thing as we did in the negative index example, where we change the entire system's prototypes and force all objects to be strict. But that would probably break all our libraries and things we're using, because they want to set things while they're running, assign new properties and so on. But you could also tweak that. You could, of course, make a version of this that allows new properties to be added, but not unknown functions to be called, for example. So you just play with this and turn it into whatever you want it to be. Or you could do the Ruby thing, where you, instead of throwing, call some default method with some default name, which can be overridden, and there you decide what to happen whenever an unknown function is called. So something we have to remember, though, when we're using proxies is, first off, that it's impossible to determine whether an object is a proxy object or not. And in general, that's kind of a good thing. And secondly, you can't access these handler methods, the implementations of get and set, from the proxy object. So you have to set it up in the beginning. Or you have to create yet another layer of proxies if you want to intercept that. And this leads us to having to figure out how to deal with this if we want to know if our objects are proxies or not. And you can do this in many different ways, of course, but a simple one is to wrap the creation of a proxy. So you have your own create proxy method, and then every time you create one, you add those proxies here to a weak set. And it has to be weak because we want it to be garbage collected when it's not used in all other contexts, even though it's in this set. And then when it's in the set, it's obviously trivial to just check if something's a proxy by calling the isProxy method. So this is something I think is adding true power to JavaScript. It's not like an arrow function, it's not like promises, it's not even like generators, even though those are more powerful than most other things. This is actually allowing you to reshape the language, to mold it differently, to make it do something completely out of the ordinary. That's like Lego. You can imagine anything, you can build anything with it. And that's cooler than many other languages in that sense. So now, I think it's kind of time for action. I want you to come up with the eval scenarios and let me know. And I also want to hear your proxy stories, either now or in the future, when you do amazing things with this. And if there's something you should take away from this talk, something I want you to think of, to remember, to use, there's 3 principles, and those are: love JavaScript because of its own strengths. Don't bolt everything onto it and nag because it's different. If what you want to do is too different, use another language. JavaScript has its own strengths. Stick to simple, powerful, generic building blocks. We want to do traditional Lego. We don't want to do this modern Lego that kids have today. And keep it simple. Don't bolt the extra legs onto a dog. So those are the principles, and then I want you to stick to 3 practices as well. And that's, you can do introspection. Don't feel like JavaScript doesn't have this, because it does. And you can use eval to do otherwise impossible things. It's not forbidden. Secondly, remember the functional nature of JavaScript. Make sure you understand it. Make sure you use this. Transform functions when you need to. And if you want to know more about that, you should attend Anjana's talk tomorrow, where she's going to talk more about functional programming. And third, proxies and prototypes. This is the true power when it comes to objects. So we have the functional stuff for our functions. We have the prototypes and proxies to make objects super powerful. And yeah, I hope after listening to this, you can love JavaScript a little bit more, because maybe you learned something completely new, or you realized some hidden potential that you haven't really thought about before. But regardless, thank you for having me, and cheers.
Поднимайте руки, если хотите задать вопрос.
Thank you very much for your talk. It was very deep, yes. You told us mostly about some superpowers, magic of JavaScript, but coming from your experience, what tools, concrete, not Lego, but concrete tools, do you find the most useful when you're developing JavaScript applications? I'm talking about functional, reactive libraries, things like that.
Do you mean in terms of libraries and so on, or? Maybe
not libraries, maybe concepts, paradigms that you think fit good in this JavaScript.
Yeah, I mean it's definitely the whole functional thing, the closures. That's the one most important thing. That's what makes JavaScript useful. If it didn't have that, it would be like a crappy version of C or something. So that's the one super important thing. It's a very generic answer, but it is. And
it is a very generic question.
Yeah, but also when it comes to tools and so on, I think JavaScript doesn't have these things to begin with. It just has the closures. The standard library is tiny, but things like underscore and Lodash and so on have kind of tried to give us some things that should have been in the standard library, and they're all built using this principle. So I think understanding that and being able to recreate all those functions yourself, if you can do that, then you understand how JavaScript should be written.
Thanks.
Еще вопросы?
Hi, thank you for your talk. Please tell what common features are you waiting if in next ECMAScript standards? Thank you.
Sorry, what I think will come or what I hope will come?
What are you waiting for you? What will be useful for you in these features?
I'm actually not sure. To be honest, I haven't read up too much on ECMAScript 7. For 6, obviously it's the proxies. This will allow us to do a lot of things we couldn't do before, and it's doing it in the optimal way, in my opinion, that it's not giving us a specific set of features, but enabling us to do whatever we want. I'm hoping for similar things in the future, very, very deep, very generic features. I don't know what's coming and what's going to be the best thing, but something I think would be interesting, maybe not for JavaScript, but a bit like Douglas said before, that maybe for the next language or the next step in programming languages would be to be better at a pragmatic level of typing, as in not dynamic typing, but having some static typing that's not getting in our way. And doing implicit interfaces, so you don't have to define beforehand that this object or this function behaves like this. But if an object has this and that function, then the rest of our code can make some assumptions about that, and so on. That I think would be very useful in a language like JavaScript as well, where we have a baggage, we can't change it, we can't make things implement interfaces they don't already have, but we could do it implicitly, for example.
Еще вопросы?
Hi, thanks to your talk. And I have a question about using same functions in JavaScript frameworks, SPA frameworks.
So JavaScript and PHP?
JavaScript.
Okay.
As we know, two of biggest JavaScript SPA frameworks using JavaScript in HTML code via attributes. They have realization of interpolation of JavaScript code, small JavaScript code in attributes. And the obvious way to make it, it's using something like eval function with construction. Mm-hmm. But when I go to the sources of these frameworks, I see that creators of them made their own JavaScript interpreter instead of making eval function. And looks like this creating of JavaScript code in JavaScript code, it's more powerful than we need. It's
more powerful than we need. Was that the question?
Yes. And the question about why exactly we cannot use it in all situations. For example, you make this example with reading of attributes of function, but when we make a function .bind to this function, we lose this magic because function toString returns no result with our attributes, with real source of function. It breaks it.
Yeah. So exactly what's the question in that, you mean?
Sorry, I'm feeling some adrenaline now, and it makes me not a good questioner maybe. But my question about maybe it's more powerful than we need, and maybe it's only for some tricky functions for my friends maybe, but not for the production.
Yeah. That's actually a good point. Like, I think most often we don't have these powerful features because we're supposed to use them every day. I don't think people will write a proxy object every day, and they won't be using the eval function every day. That would be crazy. Like, that's too much. Most of the time we don't need these things. That's true. But I think it's when we have them that we can invent and discover new things, that we then realize that this is powerful, this is something we can do something different with, and out of that a new framework or a new paradigm or a new idea is born. So it's more about our imagination and being able to use the language for fun, so like you said, with your friends and so on, than necessarily going straight to production with it. But I still think that's a very important feature, especially in a scripting language like this, where we're kind of very free to begin with. It should allow us to be free and not constrain us too much. If we want to be constrained, we should use a very different language.
Hi, thank you for your talk. I like proxy concept very much, and I was waiting so long for its support, and now it supports in very latest versions of JavaScript engines, but it can't be transpiled back because of its nature.
Yeah.
So my question is have you used proxies in some real projects, maybe in production?
I actually haven't, but I think the example I used with the strict objects would be one of the obvious ways to start using it, just to annotate, or well, say when you create an object, do you intend this to be changed or not? If not, then we lock it down like that immediately. And the price is also very low because we just add to the prototype, so we'll never actually spend any time wasting away looking at those handlers unless we need to, unless we find an unused property. So that, I think, will come into use quickly. And then I think a lot of people will invent some really smart stuff to do with this, and then we'll see new concepts and start using them.
У нас есть еще 5 минут. Может быть, у кого-то еще вопросы?
In order to understand the basic principles of functional programming, should I learn first other functional languages like Elm or Elixir?
No.
I mean in JavaScript.
Yeah, no. I think there's absolutely no need to do that. There are some with other merits. I mean, we don't have a type system here, so if you wanted to do functional programming within a type system, that's a bit different. But I think the basic principles are super accessible in JavaScript. This is a great way to learn it. So no need to look at another language to be able to do it well in JavaScript, no.
Another simple question. Should front-end developers know about these proxy things?
Yes, not a doubt. I mean, sure, front-end development is about a lot of other things than just deep down hardcore JavaScript. But it's not complicated. It's just different from writing code in a very, well, let's call it regular way. So when you get your head around it, you can suddenly be more efficient and do smarter things. And that's kind of what coding is all about, right? You want to be able to produce more in less time and make life simpler for everyone else with your programs, so why shouldn't you do it for yourself?
Hello, thank you for your talk. And my question is related to renaming arguments and getting names of arguments. And can you bring a couple of real-world examples beside writing testing framework and working with crappy legacy code?
Yeah.
Besides these two things.
Yeah.
More real-world examples.
Yeah.
Thank you.
The renaming arguments things, I don't think anyone needs in the real world. It's just a crazy example of what you can do if you wanted to, and you could do similar things that might be useful. But switching a function from taking arguments in a serial order to an arguments object is absolutely something I have used that in production code. Because instead of rewriting a whole base of legacy code where it looks in one way and you suddenly need it in another, that's actually useful. I think I mentioned during the talk that what I did was I wanted it to be called from a REST endpoint via just a URL, and you don't want the order of the arguments to matter in a URL. You want to write the names of the arguments and you want to write the values. And if that were to just call into an already existing framework that existed, I didn't want to wrap every single function with a trivial piece of code that would do the same, but just automatically wrap all of them and allow it to be called by name instead. That's a real use case I've done.
And last question.
Hello, thank you for your awesome presentation. And I have just one question. How proxy objects usage will affect on performance of my code?
I haven't done any performance testing of it since we haven't used it in production yet. But if you use it responsibly and if you're smart, like in some of these examples, I put it on a prototype that's one level beyond the actual object you're usually talking to, then it's never going to be accessed unless you end up in this special case where your proxy is useful. Unless you use a negative index, unless you call a function that doesn't exist or whatever in those examples, you would not pay any costs. And that's kind of cool, actually. So you're paying the cost when you need it. And I can't answer what that cost is, but just the fact that you don't add a constant overhead is nice.